Thank you for joining this lesson. We're going to do the Kcse 2022 Mathematics Paper 1 examination. This is the last question, number 24, whereby we are told that the triangle ABC and ABC prime are drawn on the grid provided. So on this grid, we are having triangle ABC and ABC. And ABC. Then we are told to describe fully a single transformation that mapped triangle ABC onto ABC prime for 2 marks. So let us see the relationship between these two triangles. We have the first triangle ABC, then another one now, the image ABC prime. So what I will do first is to join A and A prime, to connect A and A prime. So one thing we can see is that the triangle and its image are not equal in size. Therefore, this cannot be a rotation and this cannot be a reflection. So we can already suspect an enlargement. So let me join again B and B prime. So B is here and B prime is here. I think those 2 points are already enough, but we can also connect C and C prime. One thing we can conclude in advance is that all the lines are meeting at the origin 0, 0. Therefore, now we can see from 0, 0 to point A, from 0, 0 to point A, that is the measure of distance. And now from origin again to where A prime is, I can see we move once. Then when it stands here, we move once again. Therefore, we have 2 proportions and 1 proportion here. So we can see we have 2 times from this point of meeting to where A is, which is equivalent to the 1 point from the point of meeting to where A is. Therefore, we can again consider C and C prime. From C to the point of meeting, let me count the proportions until the other side. You can see 1, then standing here 2, until we see where C is. We can also confirm with B from the origin to where B is. Then now we count the proportions on the other side. So I can see 1, then standing here 2, we reach where B is. Therefore, here we can conclude that this is an enlargement, first of all. Now, an enlargement has a center. So the center of enlargement is origin 0, 0. And the other thing is the scale factor of enlargement, which is -2. -2 in that from the origin or from the center of enlargement, A and A prime are on opposite sides. B and B prime are on opposite sides of the center. C and C prime are on opposite sides of the center. So in such kind of an enlargement, the scale factor is given a negative. Therefore, scale factor -2. We can continue on the same grid. Now in part B, on the same grid, draw the triangle ABC double prime, the image of ABC prime, and a rotation positive 90 degrees about 0, 0. So about the origin, we are going to rotate in positive direction, 90 degrees in the positive. In the positive, this means the anti-clockwise direction. The anti-clockwise direction. Therefore, now that A has already been connected to the center of rotation, ours is to measure 90 degrees in the anti-clockwise direction. So following the line which joins A to the center, we measure 90 degrees, but now in the anti-clockwise direction. Therefore, with the compass, with the protractor there, I'm going to measure 90 degrees 90 degrees, that is the point. Then now I produce a line here. I produce a line. I produce a line such that now with my compass, I will lift the distance from this center of rotation to where A is. Then along the 90 degrees line, I'll make an arc using the same radius. So this is where my A prime is going to be. And for this matter, it is A prime double. A double prime, that is where it is. Again, I'm going to measure 90 degrees using the line which connects B to the center of rotation. Standing here, I measure 90. I measure 90. Then I produce this line now. After producing it, I again take the distance from the center of rotation to where B is. Then now B double prime will be on the other side along the 90 degrees line. This is where B double prime is going to be located. The other one is C. Therefore, C has already been connected to the center. So along the line connecting B to C to center, I measure again at the origin. I measure again 90 degrees. I measure 90 degrees. I measure 90 degrees. So standing there, I produce a line 90 degrees. Then now I lift that distance from center of rotation to C. Now I transfer the same distance to this line which is having 90 degrees. This is going to be my C double prime. C double prime. So we have C double prime, we have A double prime, which is here, and B double prime. So mine is to join so that I may get that triangle now. So this is going to be the triangle. This is going to be the triangle double prime. A prime, B prime, and C prime. So it is already connected. Let me go to part C of this question, because now we are having the object, the first image, and now the second image. In Roman 2, we are told that the triangle ABC double triple prime now, the image of ABC double prime and a reflection on the line y equals to negative x. Line y equals to negative x is the line such that when x and y are plotted, if x is 1, y should be negative 1, 2, negative 2, 3, negative 3, because the value of y is equal to negative the value of x. Therefore, we can come up with that line of, or the mirror line, in other words, because this is a reflection now. So the line such that when x is 1, y is negative 1. When x is 2, y is negative 2. When x is 3, y is negative 3. So this is the line. This is the line. Let me produce it. This is the line of the mirror line. This is the mirror line. So what we are going now to reflect is that we are going to ensure along this mirror line now. This is the mirror line. The mirror line. So what we're going to ensure is that we join all the points to the mirror line and we move an equal distance on the opposite side using a perpendicular line. Therefore, I use my compass now. Well, standing at A, I drop a perpendicular to this line such that I just need to stand here and I make an arc. I make an arc like that. Then now standing at those points, I make other arcs. to cut one another. At that point, I make an arc, and at this point, I cut the first arc such that now I can join my A with A prime. Not with A prime, but with the point of intersection of those arcs. This one means I have joined A and this mirror line using a very perpendicular line. So now mine is to lift this distance again from the mirror line to where A is to the opposite side. To the opposite side. Therefore, this is where we're going to have our A triple prime. We do the same for B. Standing here to the mirror line, I draw a perpendicular line. So I will stand here and make arcs. Such that now, standing at those arcs, I draw other arcs here to intersect at that point, and standing here, I cut the first arc. So now, when I join this arc with B, this intersection of the arc with point B, I'll have gotten a very perpendicular line. So this one, it means B and the mirror line are connected using a perpendicular line. Let me prolong it. So that now I lift the distance from this point of intersection to where B is, an equal distance on the opposite side. Therefore, at this point, I'm going to have my B triple prime. Then finally, it is C. Therefore, I join C using a perpendicular line to the mirror line. So standing at C, I construct a perpendicular to the mirror line. So that I may stand here, I produce an arc. Then standing here, I intersect the first arc. Which means I need to prolong the first arc first. At that point, and now with this other one, I prolong it like that, so they are intersecting here. So C and the point of intersection will give me a very perpendicular line to the mirror line. That is the perpendicular line. Then now standing at C, not at C, but at the mirror line on the point of intersection with the perpendicular line, now I stand at C and I lift that similar distance to this other side. Therefore, C double prime, not even double prime, C triple prime is found at this point. Therefore, now I can join C, A, and B to come up with the second image. It is even the third image of the triangle. So that is the line. Then BA is here. So this is the triangle now, triple prime. So we have the first triangle, the first image, the second image, and the third image. This is after an enlargement, after a rotation, and now after a reflection. Finally, we are told to draw the line of symmetry of triangle ABC and hence determine its equation in the form y equals to mx plus c, where m and c are constants. So what you're going to do, the line of symmetry is the line that will divide ABC, the first image, into two. So standing at B, we can bisect the angle so that the triangle will be divided into two. So standing here, we make an arc, we make another arc, then we enlarge the radius, and standing here we make an arc, then standing on the first arc we make another arc to cut the first one. Now producing a line, we will have bisected the triangle into two. This one will bisect the triangle into two. Yes, that one is a triangle bisected into two. After this now, this one is the line of symmetry now. The line of symmetry. A line that divides a certain figure into two. So this line of symmetry for the first triangle here, the first image, can be expressed in terms of its equation, whereby we'll start with identifying two coordinates. For instance, we have 6, -6, the point of B, 6, -6. Then now another coordinate along the same line is a coordinate like 3, -5. So we can first get the gradient, whereby we'll get change in y, -5, minus -6, which makes it a positive, divided by 3, minus 6. So this is going to be positive 1 out of -3. This is going to be -1/3. So with a gradient of -1/3, we can use one of the coordinates and another coordinate xy to express the equation. So y minus -5 becomes y plus 5, divided by x minus 3. Cross multiplication will give us 3y plus 15 equals to -x positive 3 when we cross multiply with -1. So to remain with 3y, we're going to have -x plus 3 minus 15 will become -12. So we can now divide through by 3 to remain with y equals to -1/3 x minus 4. So this is the line expressed in the format y equals to mx plus c.